Hi guys, good morning. Yes, can you hear me?
Sir. Good morning, sir.
Yes, good morning guys. Good morning. Can you hear me?
Yes, sir. Yes.
Yeah, thank you. Yes, if not, rejoin. Yes, if unable to hear me, just rejoin in session. Yes, let us start session. Yeah, let us start. Yes, last class about interpreter and compiler discussed. Here, all these basics completed. Yes, interpreter compiler completed. Now let us start Java. Yes, Java depends on what? Is it interpreter or compiler? Java depends on what? Is it interpreter or compiler? Let us see about Java here. Yes, Java. Let us start Java. Yes. See. Here question is yes, Java. Yes, compiler based. Java compiler based or interpreter based. Yes, compiler. Yes, is it compiler based or interpreter based? Question is Java. Yes, is it compiler based or interpreter based? Let us see this. Java. Yes, is it compiler based or interpreter based? Java, is it compiler based or interpreter based? That we should discuss. Java, is it compiler based or interpreter based? Let us see. See, except Java, in other languages, other languages, what happens here? Except Java in other languages, source code, source code, source code converts into binary code. Binary code, source code converts into binary code, source code. See, this is source code. Just code, suppose test dot. So this is source code. Java program. It's a source code. Java program source code. Yes, similarly Python scripting also discussed yesterday here. Python. Yes, Python. This is source code. So Python. Yes, this English language program is a source code. Get this source code. Yes, converts into binary code. Except Java and other languages, except Java in other languages, source code converts into binary code. That binary code given to processor. So processor, yes, taking the source code, binary code, then generating output. This is what is happening other language. Next in Java. Yes, how it works. In Java, what happens in Java? Java source code. Yes, converts into byte code. First of all, source code converts into byte code. That byte code converts into byte code, converts into binary codes. Byte code converts into binary codes. That binary code given to processor. Binary code given to processor. Okay. Source code converts into byte code to binary code to processor. Yes, processor from the generating output finally, right? Yes. Here there are two steps in Java. Two steps. Yes, other languages only one step. Only one step. Source to binary code directly. Source code converting to binary code directly. Only one step. Only one step. Yes, source code to binary codes. Yes, maybe compiler or interpreter. Suppose C language compiler. Compiler converts source code to binary code. Yes. Python interpreter converts source code to binary codes. Only one thing involving, only one. And come to Java. See source code to byte code. Source code to byte code. This part by the compiler, by the Java compiler, by the Java compiler. Next byte code. Yes, some intermediate code byte code introduced. Why byte code introduced here? Yes, byte code reason to make the Java as independent platform. Byte code introduced to make the Java as independent platform. To make the Java as independent platform. Yes, byte code to binary code. Yes, by the Java interpreter. So this is by the interpreter. Yes, by the interpreter, right? By the interpreter. That is yes. So first source code to byte code. First part by the Java compiler. Second part by the byte code to binary code by the interpreter. See here how it's working. Let us see practically. Practical example. Yes, D drive. Suppose test folder. In test folder. Yes, already Java program is there. D drive test folder. D drive test folder. Yes, Java Eclipse using. Yes, in our daily class we will be using Eclipse only. For understanding purpose, yes, I'm using Notepad. For understanding purpose, just I'm using Notepad. Yes, see command prompt, command prompt. Yes, from this go to D drive. See command prompt D drive test folder. D drive test folder. This folder, this location, this location. Open command prompt. Yes, D colon that will take to D drive. D colon will take to D drive. dir that contents. Look at the directory contents here. Directory D drive contents here. Yes, this is test directory. Test directory. See, test folder. Yes, GA calling as folder. D drive test folder. Test folder. In GA it's a folder. Same thing here. It's a directory. Test directory. Now change to test directory. CD is a command. CD means change of directory. Change of directory. Change to test. Yes, changed. CLS. Clear the screen. DR some output says test.java. Already test.java file is there. One second, notepad. I'm opening using notepad. Notepad test.java. Test.java. Yes, open that. Yes, program to say hello. Yeah, this is some program. Yes, it's a commenter. Commenter. Okay, public class test. Public static void main. Yes, here hello. Hello. Simple message hello. Save. Okay, save and exit. Not DR. Let's DR series test.java. Yes, 163 bytes. Yes, 1047 EM just now created. Yes, 65. Okay, 6th May. 6th May at 1047 this file created. Now test.java, right? Now test.java, now compilation. Java sync Java compiler. Test.java is compiling. Yes, compiled. So test.java which is source code file. So test.java. See test.java. Yes, this is source code. So this is source code. This is source code, right? Source code. Test.java source code. Okay, test.java given to Java C compiler. Test.java. So test.java. Test.java given to Java C compiler. So test.java given to Java C compiler. Java C compiler. Java C compiler. So Java C compiler. Java compiler checking for all errors. Yes, compiler checks for errors here. So compiler checking, yes, source code to byte code by the Java compiler. So yes, here Java compiler. See what happens here. Java compiler checks for all the errors, all the errors from top to bottom, all the errors from top to bottom, checking for all the errors from top to bottom, from top to bottom, from top to bottom. Yes, all the lines from top to bottom. Yes, Java program checks for errors. Checks for the errors from top to bottom. Top to bottom. Yes, if no errors, generating dot class file. Yes, if no errors. If no errors, yes, generates dot class file. dot class file. It's a bytecode. Dot class is a bytecode file. It's a bytecode file. It's a bytecode. Now here, say Java test.java source codes. Yes, source codes. Yes, Java C compiler taking test.java source codes, checking for errors, if no errors, generating dot class, tested dot class, tested dot class, generated. Yes, it's a bytecode. It's a bytecode. It's a bytecode. Code. Source code to bytecode. Source code to bytecode. Source code to bytecode. Here. See this now. Check it. Test.java compiled. Java C test.java compiled, no errors. Yes. Dot class generated. Yes. Result is dot class. Dot class. At 10:47 AM. Dot class file generated. See, I'm recompiling once again. See Java C test.java test.java recompiled. See that recompiled. Now check it here. Test.class file again generated. Yes, 10:49 AM. Just not generated. So just now dot class file generated. So this dot class is a bytecode file. This dot class is a bytecode file. It's a bytecode file. It's a bytecode file. So test.java given to Java C compiler. Java C compiler generating dot class. It's a bytecode file. Okay. Now this bytecode file. Yes. This bytecode file. Yes. See. Yes. Java test now running. Yes. Program execute. Java test. Hello output, right? Yes, hello output. So what is this Java? Yes, 1 second. So what are the steps here? First step is notepad, test.java. First step is using notepad. Yes, write the inside the notepad. Yes, open notepad. In the notepad, write the program, whatever you want. Write the program. Just writing program. Okay, save. After saving, next step is compilation. Java C test.java compilation. Compiles. After compilation, check it. Dot class file generated. Test it. Dot class file. First, using Notepad, write the program, save it. Then Java C using Java compiler. Yes, compile it. Generating test it. Dot class file at 10:51. Generated. Now run it here. Java test. Run it. Java test. Java test. Yes. Hello, right? See here. Error checking with the compiler. Compiler checking for all the errors. If no errors, then execution. Now this is what interpreter. This is compiler. This is interpreter. This is compiler. This is interpreter. That means error checking by the compiler. Program execution by the interpreter. So tested dot class file. Dot class bytecode file. Tested dot class. Tested dot class bytecode file given to a Java interpreter. That Java interpreter. Java interpreter. Given to Java interpreter. So test.java source codes given to Java compiler generating dot class file bytecode file. That bytecode file given to Java interpreter. Java interpreter. So interpreter taking the dot class file, yes, converting it to binary codes. Yes, dot class bytecode to binary code by the interpreter. Converting after binary code get given to processor. So processor taking that code, generating output. Finally, that's it. So what is happening here? So what is happening Java here? Yes, what is happening Java? See errors. Yes, program errors. Program, yes, errors checking. Errors checking by the compiler. Error checking by the compiler. Okay. Yes, no errors generating dot class file. Next, program execution. Program execution. Yes, execution by the interpreter. Execution by the interpreter. Interpreter, right? So what is happening here? Compiler as well interpreter both are involving. Yes, if it is Python only interpreter checking errors and execution, checking errors and execution. C language same compiler. C language only compiler checking for errors, if no errors generating executable, then execution here. So C language everything by the compiler. Python all are by the interpreter only here. Yes, when come to Java, what is happening here? Is it compiler or interpreter based? Now tell me guys, as per this explanation, what is Java? Is it compiler based or interpreter based? What is Java? Compiler based or interpreter based? Yes, both. So Java depends on both here. Yes, here for this answer, yes. Yes, Java. Yes, for this answer. For this answer, both. Both. So here, both are involving here. So errors checking by the compiler, program execution by the interpreter. Yes, program errors checking by the compiler. If no errors, then execution by the interpreter. Right? Interpreter. Okay. Yes. So program execution by the interpreter. See here. Previous class we discussed. Interpreter based language don't have exe, right? Interpreter. See interpreter. Yes, interpreter based language don't have exe file. Don't have exe file constraint. Try to recollect yesterday this point here. Interpreter based language don't have exe file. Interpreter based language don't have exe file. Okay. Yes, that means yes, see you program execution by the interpreter by the interpreter program execution by the interpreter, no XFL concept, no XFL concept, no XFL concept, right? See, try to understand this point here. Interpreter based language don't have exe file. That means the program execution by the interpreter, no exe file concept. Anywhere, any program which is executing by the interpreter, that is no exe file concept. The program executing by the interpreter, no exe file concept. See here, Python script executing by the interpreter, no exe file. Linux shell scripting executing by the interpreter, no exe file. HTML files by the interpreter, no exe files. Now, as per this point, tell me, Java. See, Java, errors checking by the compiler, that's okay. But program execution by the interpreter, Java program execution by the interpreter. Now, question is here. Question is, yes, can we create exe file in Java? Can we create exe file in Java? Or yes, is there any exe file concept in Java? Tell me what you understand. Yes, tell me guys, based on this, what you understand. Yes, can we create exe file in Java? See, since yes, from our last discussion, what is the last discussion? Yes, you program execution by the interpreter, no exe file concept. Program execution by the interpreter, no exe file concept. Java program execution by the interpreter. See, Java program errors checking by the compiler. Yes, Java program execution by the interpreter. Java program execution by the interpreter. See, if program execution by the interpreter, no exe file concept. Tell me. Next, one more thing here. Have you observed anywhere .exe file? Yes. First, using notepad .java file developed. Using Java compiler, generate one .class file. Have you seen any .exe file? Have you observed any .class file? Okay. Have you observed? See, Java compiler generates .class file. .class is not exe file. Java compiler generating .class file, which is bytecode file, not a binary code. Exe file means it's a binary code file. Not a bytecode file. Binary code different, bytecode is different. The differences we'll discuss in Java. Yes, in actual Java programming, I'll explain. Bytecode, binary code difference we'll discuss. Okay. Yes. Here for this answer is yes. For this answer is no. There's no exe file concept. No. Yes. No. Java don't have exe file concept. Java don't have exe file concept. Exe file concept. Java is independent of platform. Yes. No exe file concept. Java don't have exe file concepts. Okay. Yes. Java, yes, see, since Java program execution Yes, execution. Java program execution by the interpreter. Execution by the interpreter. Interpreter. Yes, interpreter. Execution by the interpreter. Yes, no execfile concept. No execfile concept in Java. No execfile concept in Java. Java is independent of platform. Okay. Since Java program execution by the interpreter, no execfile concept in Java. Java compiler generates dot class file. Dot class file is not exe file. See, Java compiler generates generates dot class file. Dot class file. Okay. Java compiler generates dot class file. C compiler generating exe file. C++ compiler generating exe file. But Java compiler it won't generate exe file. Java compiler generates dot class file. Dot class file is a bytecode file. Okay, see dot class file. Dot class file. Dot class file is not an exe file. Exe file is different. Dot class file is different here. Dot class file is not an exe file. Okay, here exe file is a binary code. It's a binary code file. Exe file is a binary code file. Yes, it is a system understandable binary code with zeros ones format. Binary code with zeros ones format. Exe file is a binary code file. It's a system understandable language. System understandable language. It's a system understandable language. Yes, what is dot class file? Dot class file is a bytecode file. It's a bytecode file. Bytecode file. Yes, it is a JVM understandable language. It is a JVM understandable language. JVM understandable language. Dot class file is a bytecode file. Dot class file is a bytecode file. Yes, it's a JVM understandable language. It's a JVM understandable language. Yes, no concept of exe files in Java. Yes, same points explained document here. Same points explained here. See, Java depends on both the compiler as well interpreter. Yes, Java errors checking by the compiler. If no errors generating dot class file. Yes, dot class file is a bytecode file. Java runtime by the interpreter. Okay, see, source code given to Java compiler, generating bytecode file dot class file given to Java interpreter. Yes, the Java interpreter bytecode to binary code converting, then finally getting output here. That links to OS library. Yes, today we'll discuss now. Next topic, linking to OS lib. Next topic now. Okay, source code to bytecode to binary code to processor, then output, right? Source code to bytecode by the Java compiler, bytecode to binary code by the Java interpreter. Yes, Java depends on both the compiler as well interpreter. Java runtime is interpreter based. Okay, see, any language runtime is program execution. Runtime is program execution. Okay, interpreter based no exe file. Yes, since Java runtime is an interpreter based no exe file concept in Java. Okay, since Java program execution by the interpreter, Java program running by the interpreter, runtime is by the interpreter, no exe file concept in Java here. Can we create exe file in Java? No. There is no concept of exe files in Java. In Java, everything is dot class file. Dot class file is not an exe file. That is different. This is different here. Exe file is a binary code file. It's a processor understandable language. Okay, dot class file is a bytecode file. It's a JVM understandable language. Yes, exe file is a OS dependent. Dot class is independent of platform. Exe file is OS dependent. Yes, dot class file is independent of platform. Yes, same point. Now we are going to discuss. Yes, Java is an independent of platform. Now this topic we should discuss. Okay. Yes. Yes. Java is an independent platform. Java is an independent platform. Java is an independent platform. What does it mean? Java is an independent platform. What does it mean here? What does it mean here? What does it mean? Let us see. What does it mean here? Yes, independent platform. means Java program running anywhere. Java program, Java program, yes, Java program, Java program, Java program, Java program can run on anyways. Okay, Java program can run on anyways. That's the meaning of independent platform. Independent platform means Java program running on anyways without any changes. Java program running on anyways without any changes, without any changes in the program, without change in the any change in the program. That's the meaning of independent platform. That's okay, fine. Now question is how Java made us how Java made us independent of platform, independent of platform. That's the question. Yes, that is topic now. Okay, how Java made us independent of platform. How Java made us independent of platform. For this purpose, yes, you must have the exe file knowledge. Let us see about exe file, about exe file, about exe file, about exe file. Okay. So what is exe? First of all, what is an exe file? What's an exe file? What's an exe file? Yes, exe file is a binary code for C. exe file is a binary code for it's a system understandable language. It's a processor understandable language. What is an exe file? Yes, exe file is a binary code for it's a processor understandable language. It's a processor under system is a processor. It's a processor understandable language. Right? Yes, what does it contain? The question is here, what does it contain? What does it contain here? Yes, exe file contains what here? Let us see. For example, here C program exe file, C program exe file, C program exe file prepared. Yes, on Windows base. Prepared on Windows base. Windows. Yes, some question for you guys. One second. Some questions. C program exe file prepared on Windows base. Yes. Can I run on Linux? That's the question. Anyone can answer this. Yes. C program exe file prepared on Windows base. Can I run on Linux base? Can I run on Linux base? C program exe file prepared on Windows base. Can I run on Linux base? Let me check the answers. Yes, everyone saying that no. Good. Yes, no. Reason is exe file is a OS dependent. Exe file is OS dependent. Exe file is a OS dependent. Why exe file is OS dependent? Immediately question. Why exe file is OS dependent? Why exe file is OS dependent? Anyone can you tell me? Answer for this. So why exe file is OS dependent? Yes. Exe file is a OS dependent. That's okay, fine. Exe file is a okay. Exe file is a OS dependent. That's okay, fine. Yes, why exe file is OS dependent? Anyone? Why exe file is OS dependent? Platform dependent or OS dependent, same meaning. Platform dependent, OS dependent, same meaning. Why exe file is OS dependent? Yes, for this purpose. Yes, for this purpose, you must have the exe file knowledge. For this purpose, you must have the exe file knowledge. For example, get C program. Yes, C program exe file. C program exe file generated on Windows base. Then it contains what? Then it contains yes. Let us see. So this is C program. I'm opening C program. This is C program. Here there is a main function. C program. Yes, backend of the C program. Yes, in C drive installed a C drive. Okay, C drive. Yes, turbo C folder. Turbo C folder. Yes, in turbo C here. Bin folder. Yes, what is name of the program file? Math.cpp. Math.cpp. Yes, yesterday some topic discussed about this. Math. Okay. Yes, this is math.cpp. Yes, just now it's saved, right? Just now saved here. Saved. So the time of modification 11:8 a.m. 6/5, 6th May 11:8. Just now file modified. Now 11:8. Math. Okay. Yes. Now here. One second. Without confusion, I'm deleting that math name. Deleted. Yes. Math.cpp. Now compile. Yes. Once she compiles. Yes. Something happened. See this. Math.obj file generated 11:10 a.m. Math.obj. So dot obj. Yes, dot obj is a binary file. So what is this binary file? It contains what? Binary code zeros ones for what is dot obj file? Discuss. See here. C program. This C program. Void main int abc. That complete program converts into binary code. C compiler converts this whole code into binary format and writing to math.obj file. So math.obj file generated. So this contains what? Binary code for our C program. Binary code for the C program. This contains binary code for C program. Next, in the same program, here they say stdio data conjugate data address file. These address files are predefined address files, already developed, already available. These address files also having binary codes. These address files also having binary codes. Okay, now run this. When you try to run it, first of all, it creates exe file. See this .exe file created. .exe file. .exe file created. See math.exe file created. Yes, what happens at the time of creation of this exe file? How this exe file creating here? Now, compiler taking math.obj means binary code for our C program. Binary code of our C program plus binary code for OS library. Binary code for OS library. Binary code for OS library means here stdio data and conjugated. Yes, sorry. Binary code for C library. stdio data and conjugated data. So you can at the time of creation of exe file, what happens here? C compiler taking binary code for our C program means math.obj file plus binary code for C library stdio data and conjugated data. Yes, behind of this binary code, that library files binary code here. Binary code. Yes, apart from OS library, Windows OS library. By linking out all of this in generating exe file. Generating exe file. The C program exe file generated on the Windows OS, then it contains here. Yes, binary code. Yes, binary code. Binary code. Binary code. Binary code. Yes, binary. Binary code for C program. Binary code for C program. Plus, yes, binary code. Binary code for C library. 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 Plus binary code for OS library. Binary code for OS library means here is a Windows OS library. Yes, Windows OS library. Windows OS library. By linking of all of these things generates exe. Okay. So here exe file is linked with OS library. Yes, OS library. See previous classes. Previous classes. Yes, in OS concepts. See previous class. See here, this point, last point. Every program has to link with OS library before going to start execution. This is yes. Every program has to link with OS library. That program linking with OS library. Yes, it's OS library. In OS this input output library. OS this input output library. In OS this input output library. So what happens here? Yes, that is linking with Windows OS library. C program exe file generated on Windows OS. Then it contains binary code for C program, binary code for C library, and binary code for Windows OS library. By linking all of this in generating exe file, that is exe file exactly. Okay, that is exe file. Yes, one more example. One more example. Suppose C program exe file prepared on Linux OS. Linux OS. Linux OS. Linux OS. Here Windows OS, here Linux OS. Linux OS. Then it can as binary code for C program, binary code for C library, binary code for Linux OS library. Linux OS library. Okay. Yes, one more example. Let us take one more example. One more example. C++ program exe file. One more example. C++ program exe file. C++ program exe file generated on Linux OS or Windows OS. Windows OS. Windows OS. Then it contains binary code for C++ program. Yes, plus binary code for C++ library. C++ also having library. Next, binary code for Windows OS library. Binary code for Windows OS library. That's it. That means what happens here? Always, yes, OS library linking with exe file. That exe file always linking with OS library. So what is happening here? So here always exe file, yes, linking with OS library, OS library, OS library. See, always, okay, on every ways, yes, that exe file is linking with OS library. Okay, yes, that linking happens at the time of creation of exe file. That linking, yes, linking takes place. Linking takes place at the time of creation of exe file. At the time of creation of exe file, exe file. The linking takes place at the time of creation of exe file. Yes, it is called as static linking. It is called as static linking. Static linking. It is called as static linking. Okay, so exe file statically links with OS library. Okay, yes. So exe file, yes, statically, yes, linking with OS library. Yes, statically means at the time of creation of exe file itself linking here. Yes, linking takes place at the time of creation of exe file only here. Yes, it is called a static linking. That link is fixed, never changes. Okay, yes, now here, for example, here, Windows-based exe file. For example, let us take it. Windows-based exe file. Yes, Windows-based exe file on different platforms. How it works on different platforms. Yes, how it works. Okay, so Windows-based exe file. See, Windows-based exe file. Yes, exe file contains. Yes, Windows OS library. Win library, right? That Win library. Okay, yes. Windows based, so for example, test.exe file. Yes, prepared on Windows OS. Then yes, it contains. Yes, Windows OS library. Right? Yes. Not test.exe file with Win library on different platforms. How it works? Okay, test.exe file with Win library on different platforms. On different platforms. How it works? On different platforms. How it works, let us see here. How it's working, let us see. Okay, test.exe file. Yes, let us take different platforms. Different platforms. Yes. First hardware. 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 Yes, on top of hardware. See hardware. On top of hardware. Yes, Windows OS running. Windows. Yes, already we discussed about that point here. Hardware. On top of it, Windows OS running. Yes, on top of it, exe file. Yes, Windows OS. Windows OS. Yes, with Win library. Right? Yes, on top of it, test.exe file. Test.exe file. Okay. Yes. Here test.exe file. Test.exe file. Okay. So test.exe file. Test.exe file placing on Windows Server. Test.exe file running on Windows platform. Now, when you try to run it here, yes, test.exe file, it will try to call to Win library. Win library. Yes, here it's available. The test.exe file, it will try to call to Windows library here. It will try to call to Windows library. Yes, available. Yes, it's available. You're using that library communicates with hardware component. That's it. See test.exe file already linked with the Windows OS library. Test.exe file already linked with Windows OS library. Okay, directly calling to Windows OS library. Already linked. Already linked. Just the calling Windows library. Yes, available. Using that library communicates with hardware. That's it. Okay. Yes. Next. Same test.exe file on another platform. Let us take another platform. Linux platform. Linux base. No Linux base. With the Linux library. Linux base with Linux library. Okay. Now same test.exe file. Same test.exe file placing on Linux base. Now try to run it. When you try to run it here, now this test.exe file, yes, it will try to call to Windows library only because already linked. Instead of test.exe file, that Windows OS library is there. So since linked with Windows OS library, it will try to call Windows library, but here Linux library. So that library is not matching. Yes, is test.exe file, it will try to invoke. See, in this case, test.exe file invoking Windows library. Yes, available. Using that communicates with hardware. Yes, here any program using Windows, yes, sorry, any program using OS library to communicate with hardware. Okay, see all the programs, see every program. Yes, every program has to link with OS library. Programs are linking with OS library. Using library communicates with hardware through the library, compulsory through the library. Yes, it's happening through the library. It's happening through the library. Just happening through the library. Just happens through the library here. Everything happens through the library. Okay. Yes. Yes, happening through the library. So happening through the library, right? Happening through the library. Yes. Now here, test.exe file. Yes. It will try to call the Windows OS library, but here it's not available. The library is not matching, simply fails. Library is not matching, simply fails. Library is not matching, simply fails. Okay, let us take another platform. Suppose Unix base. Unix lab, same problem here. Unix base with Unix library. Yes, not matching. Yes, test.exe file try to call Windows library. Try to call to Windows library, but not matching. Yes, again fails, here fails. Similarly on Mac base, again fails. So running on only Windows first because that is exe file is already linked with OS library. Okay, yes, since exe file, yes, since exe file contains OS library, yes, it's a OS dependent, it's a OS dependent, that's it here. OS dependent, OS dependent, since exe file contains OS library, it's a OS dependent here, that's it here. Okay, see here question, where is question here? This here, why exe file is OS dependent? Answer. That's it. Okay, so this is about exe file. Now let us come to Java. Yes, same thing Java. In Java, it's a dot class file. Now let us come to Java. Java. Yes, in Java, what happens here? Let us see Java. Java program. Java program. Hello. Oh, which yeah. Yeah, Java program. See, in Java program, dot class file. Dot class file. Java program dot class file generate a Windows face. Yes, then it contains binary code for, yes, 1 second, some important message, just a minute. Yeah. Now Java program dot class file. Java program dot class file. Java program dot class file generate a Windows face. Then it contains, yes, binary code, not binary code. It's a byte code. Byte code for Java program. Byte code for Java program. Next, byte code for Java library. Byte code for Java library. Next, binary code for OS library. No. No, only Java code. No OS library here. Okay, byte code for Java program, byte code for Java library. See, Java library also developed in Java. Java library also developed in Java. So dot class file. Dot class file. See, dot class file is a pure Java program. Pure Java program. Yes, dot class file is a pure Java program. Yes, in bytecode format. In bytecode format. That is dot class file. Bytecode format. Okay, dot class file is a pure Java program in bytecode format. Okay, dot class file. Yes, dot class file don't have any OS library. Dot class file don't have any OS library. Okay, yes, it is free from from OS library. It's a free 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 from OS library. So dot class file is free from OS library. Dot class file is free from OS library. Okay. Yes. Now dot class file and different operating systems. Dot class file. Suppose testy dot, for example, testy dot class file. See testy dot, for example, testy dot class file prepared. Testy dot class file prepared. Testy dot, for example, testy dot class file tested.class file prepared on any OS. For example, tested.class file prepared on any OS. Yes, it don't have any OS library. It don't have any OS library. It don't have any OS library here. Any OS library. It don't have any OS library. Okay, dot class file. See, dot class file prepared on any OS. That may be prepared on any OS, maybe Windows OS, Linux OS, Unix OS, any OS, but you don't have any OS library. So dot class file is always free from OS library. Okay, no dot class, no tested dot class, tested dot class file. Yes, yes, running on working on different platforms, working on different platforms, working on different platforms. Let us see how it's working on different platforms. So how dot class file? Yes, yes, how dot class file working on different platforms? How dot class file working on different platforms? Yes, let us see how it's working. Yes, let us take. See, let us take Windows OS, tested dot class file and Windows OS. Okay, see tested dot class file on Windows OS, how it's working. Okay, no tested dot class file. So tested dot class file. So tested dot class file. Yes. Not tested dot class file placing an Windows OS. Can I run it directly here? Yes, to run this tested dot class file, first of all, this dot class file has to link with OS library, but not linked. Where is linked? It's not linked. The dot class file is not linked. Yes, every program has to link with OS library. See, every program has to link with OS library. Otherwise, cannot run. Yes, linking with OS library and communicate with the hardware. Otherwise, cannot. No, Java program also has to link. Java program also has to link here. Yes, but here it is not linked. Tested dot class is free from OS library. Dot class file don't have any OS library, not linked, but it has to link. Then how? So between dot class file and Windows OS, one more layer come to picture. Between dot class file and Windows OS, one more layer come to picture. What is that layer? One more layer comes to picture. What is that layer? Can you guess it? Between dot class file and Windows OS, one more layer come to picture. Yes, what is that layer? One more layer come to picture. That layer is a JVM. JVM come to picture. Java Virtual Machine. JVM. JVM is a Java Virtual Machine. JVM it's a Java Virtual Machine. JVM come to picture. Now JVM will come to picture. JVM will come to picture. So JVM will come to picture. Here JVM will come to picture. JVM will come to picture. Okay, JVM, yes, will come to picture. Now JVM taking test dot class file. JVM taking test dot class file links with Windows OS library. That's it here. Once linked with Windows OS library, then execution generating output. That's it here. Yes. Let us take another platform. Another platform, Linux platform. Yes. Let us take Linux platform. Linux platform. No Linux platform. Yes. Same dot class file on this platform. So Windows JVM taking dot class file links with Windows OS library. No, same dot class file. Yes, on Linux system. 1 second. Hello. వచ్చినాయి. యా వచ్చినాయి. మెసేజ్ వచ్చింది నాకు. Yes, Linux based with Linux library. Right? Now this case what happens here? Yes, on Linux also there is a JVM. Now Linux JVM taking your test.class for links with Linux based library. That means whenever we is changing, that link is changing automatically. Link changing here. Link changing. So next platform. Let us take another platform. Yes, Unix platform. Yes, Unix platform. Same happens here. Unix platform. Unix base with Unix library. Unix base with Unix library. Yes, now on this Unix base, there's a JVM. Unix JVM. Taking dot class for links with Unix base library. That's it here. So what is happening here? The dot class for is linking to different operations dynamically. Before going to execution, linking then execution. So every time of changing ways, that link is changing. Every time of changing ways, that linking changing, correct? Who is changing link here? JVM. JVM changing link, right? JVM changing link, that link is changed with JVM, right? Okay, so you get tested dot class file, Java, see Java dot class file, Java dot class file, yes, links to current ways, current ways library, yes, library, yes, by the JVM. So you get JVM links dot class file to current ways. So every time of changing ways, that link changes here. Every time of see every time of changing ways, link changes. Okay, so dot class for dynamical links to ways library here. Okay, here since dot class file, dynamically, yes, linking to different operating systems. Yes, linking to different operating systems. Yes, it's an independent platform. It's an independent of platform. Independent platform. That's it here. Since dot class for dynamically linking to different operating systems, yes, it's an independent platform. That's it here. So you get JVM. Yes, here JVM. Yes, JVM makes Java program as independent platform. Java program as independent platform. So beginning of this is a JVM here. Independent platform. That's it here. Independent platform. So behind of this is JVM. JVM makes it Java program as independent platform. That's it here. Yes, in the exe file statical linking. Exe file is statical linking, that is way is dependent. But dot class for dynamical linking. Since dot class for dynamical linking, it's an independent platform. That's it here. Even Python scripting also dynamical linking. Python script also dynamically linking to ways library. So Python scripting are independent platform. See, any program which is linking dynamically with ways library, that is independent platform. Java program linking with ways library dynamically. Python scripting also linking with ways library dynamically. So these are independent platforms. Okay, now here question is some doubt here. So Windows ways with JVM, Linux ways with JVM, yes, Unix with JVM. Now JVM, is it part of OS? JVM, yes, is it part of OS? No. JVM is not from the OS. JVM, see, JVM is not a part of OS. JVM is not a part of OS. It's not a part of OS. Yes, it is from JDK software. JDK means Java Development Kit. JDK software. It is from JDK software. Okay, JVM is from the JDK software. Okay, JVM is not a part of it. It's not a OS part here. It is from the JVM. It's from the JDK here. JDK, right? Okay. Yes. Yes, to get JVM on different operations. on different operations. Yes, on different operations, JDK should be installed. JDK, yes, should be installed. JDK should be installed on OS. That's it. Once OS installed, getting JVM automatically. Without installing JDK, you can't get it here. Okay, to get JVM on different operations, JDK should be installed on the OS. Otherwise, you cannot. Next, one more point. Yes, JVM. Yes, JVM developed in C++. Yes, it's a C++ exe file. Yes, it's a C++ exe file. It's a C++ exe file. JVM is a C++ exe file. JVM is a C++ exe file. JVM is a C++ exe file. Yes, if it is exe file, then what? Yes, if it is exe file, JVM is a C++ exe file, means it's a OS dependent. Okay, see, Java dot class file. Java dot class file is a independent of platform, independent of platform. But JVM, yes, is a OS dependent. Reason it's exe file. Yes, it's a C++ exe file. Reason, yes, it's a C++ exe. It's a C++ exe file. It's a C++ exe file. It's a C++ exe. It's a C++ exe file. That's it here. It's a C++ exe file. That's it. Okay, Java program is independent of platform, but JVM is a OS dependent because it's a C++ exe file. Okay. Yes, definitely. That increases execution time. Yes, it makes a call to C++ layer, C++ program, calling C++ program, definitely taking time. Yes, C++ exe file execution faster than the JVM, Java program, because JVM involvement is there. Okay, so C++ exe file executes faster than Java program dot class file because JVM involvement. Okay, right? Yes. Now here, a Java program is independent of platform JVM, but JVM is a OS dependent. Reason it's a exe file, C++ exe file. Okay. Yes, JVM from the JDK, right? Yes. Since JVM OS dependent, JDK also OS dependent. Okay. Yes, since JVM OS dependent, JDK also JDK. Yes, JDK also OS dependent. JDK also OS dependent. Yes, for different operations, different JDK you have to download it. See, right? See JDK for Windows OS. See, the JDK changes. OS to OS JDK changes. Download JDK 1.8. See JDK. See here JDK. Linux. JDK for Linux OS. JDK for Mac OS. Yes, they are all JDK softwares. Yes, Oracle site. In Oracle sites, all JDK softwares. Okay. Linux. JDK for Linux OS. JDK for Mac OS. JDK for Solaris. And JDK for Windows OS. That's it. Okay. So JDK depends on, yes, OS. Because JVM is OS dependent. That's it here. So different JDKs you have to download it here. Yes, you guys, no worry. Yes, I'll provide JDK. Suppose using Windows OS, I'll provide JDK for Windows OS. Suppose some guys may be using Mac OS. Yes, I'll provide JDK for my Mac OS. I have all the different JDKs. I will provide it. You guys don't worry. Okay, from your Google Drive you can download it. Yes, I think almost all guys shared already. Okay, Yes, almost everyone paid. For all paid students, JDK shared, Java software shared, class document shared, everything is shared. Just go to Google Drive and download it. Yes, almost everyone paid. Okay. Yes, I think more than 10 members paid. Yes, I think 12 members were paid here in your batch. Somebody, yes, attending classes, somebody taking, yes, videos. Okay, fine. Yeah, this is independent platform. I think clear, right? How Java made us independent platform. Reason is this. Yes, you understand, guys? Now see this. Yes. Dot class file exe file. What's the difference here? Exe file dot class file differences. Yes, exe file dot class file difference. Exe file dot class file difference here. See what is main difference? Exe file is a binary code file. Dot class is a byte code file. Exe file is binary code. Dot class is byte code file. Byte code, binary code, the differences we'll discuss in Java programming. Byte code, binary code, the differences I'll explain in Java programming. Next coming topic. Next here, main difference OS library. Exe file contains program code, software library plus OS library. Yes, here don't have dot class file, don't have any OS library. Dot class file don't have any OS library. Okay, exe file is a prepared file for specific OS, but dot class file is not a prepared file. Don't have any OS library. Next, exe file. OS library statically linking with exe file. Dot class OS library dynamically linking with dot class file. That's it here. Yes, exe file is already prepared one before moving to OS. Already prepared then running here. Yes, dot class file is not a prepared file. See, after placing on the OS, JVM prepares as per current OS. JVM prepare means linking to current OS. That's it here. Okay, exe file executes faster than dot class file. Okay, dot class file, yes, preparing at run means JVM involving. It executes slowly, somewhat slow, not, yes, not too slowly here. Yes, little bit slow. Compared to dot exe file, dot class file, little bit slowly running here. So this is difference, exe file, dot class file, that's it here. That's it. See, this kind of explanation, no trainer will give you. I'm sure 100%. No trainer will give this kind of explanation. Okay. Yes, even websites also. Java websites, many Java websites are, check it. How Java made us independent platform. Just check it. Yes, no website will give this kind of information. Okay, no trainer will give this kind of explanation here because, yes, here see exe file knowledge. Yes, exe file knowledge. The trainer must have the first of all exe file knowledge. Means the trainer should work on embedded C also. Yes, I have a lot of experience in different areas. Embedded C experience, Java experience, OS experience. So with that experience only, I'm able to explain this. Yes, Sarah, go to Google Drive and check, share it with me. You can see in Google Drive it's available. Yes, upload it to Google Drive. In Google Drive you can see. From the Google Drive you can download. Okay. Yes, same. It's there in document. Same this file. Our document, class document and today topic is same. Class documents, in class document, everything is there. Same topic is there in document. Yes, of course, I'll share in WhatsApp group also. Yeah, today topic, this one. Okay, independent platform. I'll share in WhatsApp group, no worry. Java 10:30 AM. Yes, independent of platform. Top. Yes, J5. Yeah, that's all for today. Tomorrow topic is Java installation. Okay. Tomorrow topic is Java installation. Tomorrow installation. Yes, tomorrow starting programming. Yes, all the basics completed. All the introductions completed here. Tomorrow will be starting Java installations. Okay, yeah. So that's all for today. Tomorrow also same link. No change in link. See, classes Monday to Saturday classes. Monday to Saturday classes. Tomorrow Saturday, even Saturday taking class. Only Sunday holiday. Tomorrow also same link, no changes. Yeah, that's all. So thank you guys. See you tomorrow.